Hello and welcome everyone. Today we are going to start a new chapter, and that chapter's name is whole numbers. So in this chapter we are going to learn about the subtopic natural numbers. Why do we need numbers? Numbers are one of the most important tools in our life, whether it is a phone number or the number of the students in our class. Numbers are used everywhere, as numbers play such important roles in our day-to-day life. It is essential for us to know and understand numbers. We know that in the Hindu-Arabic number system, the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 are used to form the numbers. Natural numbers. We mostly use numbers to count the number of things, right? Yeah. All these numbers are called counting numbers. Counting numbers are used for counting. But counting numbers are also called natural numbers. Natural numbers start from 1 and end at infinity. One thing we need to know is that natural numbers are always positive. We also need to know that whole numbers start from 0 and end at infinity. One difference between natural numbers and whole numbers is that natural numbers start from 1, but whole numbers start from 0. This is one diagram to help you understand the difference between natural numbers and whole numbers. So, what did we learn today? Today we learned why do we need numbers and about natural numbers. So if you guys like the video, please like, share, subscribe and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Hello and welcome back everyone. Today we are going to continue with the same chapter, whole numbers. But in this chapter we are going to learn a new subtopic. Subtopic's name is properties of whole numbers. So let's start the lesson. What is the property of whole numbers? The whole numbers are the part of the number system in which it includes all the positive integers from 0 to infinity, but do not include fractional or decimal parts. The properties of whole numbers based on arithmetic operations, which are addition, subtraction, multiplication and division. The two whole numbers, if added or multiplied, will give a whole number itself. But when we subtract two whole numbers, we might not always get a whole number. It can also be an integer. Also, division of two whole numbers does get results in getting a fraction in some cases. So, we are going to learn about now the closure property of whole numbers. In addition, when we add two whole numbers, the sum will always be a whole number. For example, x plus y is equal to z. So, we can change that to 7 plus 8 is equal to 50. In these, the answer and both the added are all whole numbers. In multiplication, when we multiply two whole numbers, the result will always be a whole number. For example, x into y is equal to z. So we can change that by 7 into 8, which is equal to 56. In this, the multiplicand and multiplier and the product are all whole numbers. In subtraction or division, when you subtract or divide two whole numbers, the result will not always be a whole number. For example, in subtraction, x minus y is equal to z. We can replace that by 7 minus 8, which is equal to minus 1. And in division, for example, will be x divided by y, which is equal to z. We can replace that by 7 divided by 8, which is equal to 7 by 8. In both subtraction and division, the numbers are the product or the sum are not a whole number. So that means only closure property only works in addition and multiplication, not in subtraction or division. So now let us learn commutative property of whole numbers. In addition, the sum of two whole numbers will not change even if the orders of the number are changed. For example, x plus y is equal to y plus x. We can replace that by 7 plus 8, which is equal to 15, and if we even change the order, 8 plus 7 is also equal to 15. In multiplication, the product of two whole numbers will not change even if the order of the numbers are changed. For example, x into y is equal to y into x. Or we can replace that by 7 into 8, which is equal to 56. And if we change the order, it will be 8 into 7, which is equal to also 56. In subtraction or division, the difference or quotient of two whole numbers will change if the order of the numbers are changed. In subtraction, for example, x minus y is not equal to y minus x. We can replace that by 7 minus 8, which is equal to minus 1. But if we change the order, it will become 8 minus 7, which is equal to 1. For example, in division, x divided by y is not equal to y divided by x. So if you replace that by 7 divided by 8, which is equal to 7 by 8, and if we change the order, it will be 8 divided by 7, which is equal to 8 by 7. And we already know fractions, so 8 by 7 is an improper fraction. So to make it a mixed fraction, it will become 1 by 7. So this also means that commutative property only works in addition and multiplication, not in subtraction or division. Now we will learn about the associative property of whole numbers. In addition, when three or more whole numbers are added, the sum will not change even if the groups are changed. For example, x plus y plus z is equal to x plus y plus z is equal to x plus z plus 1. So we can replace it by 7 plus 8 plus 9 is equal to 15 plus 9, which is equal to 24. And then 7 plus 9 plus 8 is equal to 16 plus 8, which is also equal to 24. And 7 plus 8 plus 9 is equal to 7 plus 17, which is also equal to 24. In multiplication, when three or more whole numbers are multiplied, the product will not change if the groups are changed. So for example, x into y into z is equal to x into y plus into z is equal to x into z into y. We can replace that by 7 into 8 into y, which is equal to 56 into 9, which is equal to 404. And 7 into 9 into 8, which is equal to 63 into 8, which is equal to 404 also. And 7 into 8 into 9, which is equal to 7 into 72, is also equal to 404. So that means in addition and multiplication, both all the answer, the sum and the product will be the same. It will not change. The difference between commutative and associative property is that in commutative property this works for only two numbers, whereas for associative property it works for three or more whole numbers. So in subtraction or division, when three or more whole numbers are subtracted or divided, the sum will change when the groups are changed. So for example, in subtraction, x minus y into minus z is not equal to x minus y into minus z is not equal to x minus z minus 1. So for example, in subtraction, 7 minus 8 minus 9 is equal to minus 10, and 7 minus 8 minus 9 is equal to 8, and 7 minus 9 minus 8 is equal to 16. So the sum will change if the order of the numbers are changed in both subtraction or division. So that also means that associative property works only in addition and multiplication, not in subtraction or division. Now we will get a summary of closure, commutative and associative property. This means that closure, commutative and associative property both work in addition. All three work in addition. All three do not work in subtraction. All three work in multiplication, and all three do not work in division. Now let us learn about the distributive property of multiplication. Distribute means to give each member of the group, like a newspaper man delivers newspaper to each house of the community. Distributive property of multiplication over addition. This property is used when we multiply a whole number by a sum of two whole numbers. We first must multiply each added and then add the products. So for example, 5 into 8 plus 4, which is equal to 5 into 8 plus 5 into 4, which is, and 5 into 8 is equal to 40, and 5 into 4 is equal to 20. So 40 plus 20 is equal to 60. Distributive property of multiplication over subtraction. This property is used when we multiply a number by a difference of two whole numbers. We first multiply subtrahend and minuend with the outside number, then subtract the products. For example, 5 into 6 minus 3, which is equal to 5 into 6 minus 5 into 3. 5 into 6 is equal to 30, 5 into 3 is equal to 50. So 30 minus 50 is equal to 50. Distributive property of multiplication over versus order of operation. Distributive property is used to make a calculation easy. So now we will try to solve two questions in order of operation, which is equal to 8 into 50 plus 3. So which is equal to 8 into 50. We don't know the tables of 53. So we will not be able to do this multiplication. It's not that much easy, isn't it? 3 into 400 plus 23, which is equal to 304. 3 into 420. We don't know the multiplication table of 423. So this isn't so easy, isn't it? But now, if we try to solve these questions in distributive property, we will be able to get the answers very easily. Let's try to solve these now. 8 into 50 plus 3, which is equal to 8 into 50, which is equal to plus 8 into 3. And we don't need to know the multiplication table of 50 to know this, because we can just take 8 into 5, which is equal to 40, and after getting 40, add a 0 at the end. And if you all know the multiplication table of both 8 and 3, so 8 into 3 is equal to 24. That is equal to 400 plus 24, which is equal to 424. Isn't that easy? Now let's try to solve our next question, which is 3 into 400 plus 23. 3 into 4, which is equal to 300 into 400 plus 3 into 23. For this, we don't need to know the multiplication table of 400. So we can just take 3 into 4, which is equal to 12, as we all know, and then add two zeros at the end. which is equal to 1200. And we also don't need to know the multiplication table of 23 full. We can just do 3 into 2, which is equal to 6, and then we'll add a 0 at the end, which is equal to 60. And 3 into 3 is equal to 9. So 60 plus 9 is equal to 69. That'll make our answer to 1200 plus 69. And if we do the addition, it will become 1269. Isn't it easy now? Now we will learn about the property of 0. The subtractive property of 0. If 0 is subtracted to a whole number, then the value will be same of the whole number. It will not change. So for example, x minus 0 is equal to x only. We can replace x by 7. We'll get 7 minus 0, which is equal to 7 itself. Multiplicative property of 0. If 0 is multiplied to any whole number, the value of that whole number will become 0. So for example, x into 0 is equal to 0, and 0 into x is also equal to 0. So if we replace x by 7, we get 7 into 0, which is equal to 0, and 0 into 7, which is also equal to 0. Now we will learn about the property of identity. Additive identity. If 0 is added to any whole number, the value of the whole number will be the same. It will not change at all. So, for example, x plus 0 is equal to x, and 0 plus x is also equal to x. So, if we replace x by 7, we get 7 plus 0, which is equal to 7, and 0 plus 7, which is also equal to 7. The multiplicative identity. If 1 is multiplied to any whole number, the value of the whole number will be same. It will not change at all. So for example, x into 1 is equal to x, and 1 into x is also equal to x. So if we change x by 7, we get 7 into 1, which is equal to 7, and 1 into 7, which is equal to 7. So, what did we learn today? We learned what is whole number and its properties, the closure property of whole number, commutative property of whole numbers, associative property of whole numbers, difference between commutative property of whole numbers and associative property of whole numbers, the distributive property of whole numbers, the distributive property of multiplication versus the order of operations, the property of 0, and the identity property. So if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Bye. Hello and welcome back everyone. Today we're going to continue the same chapter, whole numbers. But today we're going to learn about the subtopic representing whole numbers on a number line. So let's start. How to represent numbers on a whole number line? We are already familiar with a number line. The distance between two consecutive digits on a number line is called the unit distance. So we can represent whole numbers on a number line. To create a number line, we will have to follow the steps which is given below. First, we have to draw a straight horizontal line. Then we have to mark the extreme left and label it as 0. Then we have to mark another point to the right of 0 and label it as 1. The distance between the point 0 and 1 is called the unit distance. Then we have to mark one more point to the right of 1 and label it as 2. To finish the number line, we have to keep marking points and labeling them as 3, 4, 5 and so on at equal unit distances. Now we will learn how to add numbers on a number line. It does add two whole numbers, say 5 and 4 on a number line. Let us start from 5. To add 4 to 5, we have to take 4 units to the right of 5. The jumps are from 5 to 6, 6 to 7, 7 to 8 and 8 to 9. This is how it will be on a number line. So 5 to 6, 6 to 7, 7 to 8 and 8 to 9. With the fourth jump, we reach at 9. So thus, 5 plus 4 is equal to 9. Now we will learn how to subtract numbers on a number line. Let us subtract two whole numbers, say 3 from 7 on a number line. Let us start from 7. To subtract 3 from 7, we need to mark 3 units to the left of 7. The jumps are from 7 to 6, 6 to 5 and 5 to 4. This is how it will be on a number line. So it will be 7 to 6, 6 to 5 and 5 to 4. With the third jump, we reach at 4. Thus, 7 minus 3 is equal to 4. Now we will learn how to multiply numbers on a number line. We know that multiplication is just basically repeated addition. To multiply whole numbers, we need to start from 0 and jump several units at a time for a number of times. It only depends on upon the value of the multiplier and multiplicand. So now we will learn how to multiply on a number line. So let us multiply two whole numbers, say 3 and 5 on a number line. Let us start from 3. To multiply 3 and 5, we have to jump 3 units to the right 5 times. The jumps are from 0 to 3, 3 to 6, 6 to 9, 9 to 12 and 12 to 15. So this is how it will look on a number line. So the jumps are from 0 to 3, 3 to 6, 6 to 9, 9 to 12 and 12 to 15. With the fifth jump, we reach at 15. Thus, 3 into 5 is equal to 50. Now we will learn how to divide numbers on a number line. We know that division is just basically repeating subtraction. To divide whole numbers, we need to start from the bigger number and jump several units at a time for a number of times. It only depends upon the value of the divisor and dividend. Now we will learn how to do it on a number line. Let us divide two whole numbers, say 14 and 2 on a number line. So let us start from 14. To divide 14 and 2, we need to 2 units until we reach 0. The jumps are from 14 to 12, 12 to 10, 10 to 8, 8 to 6, 6 to 4, 4 to 2 and 2 to 0. So this is how it will look on a number line. 14 to 12, 12 to 10, 10 to 8, 8 to 6, 6 to 4, 4 to 2 and 2 to 0. With the seventh jump, we reach at 0. So thus, 14 divided by 2 is equal to 7. Therefore, to summarize, what did we learn today? We learned how to represent whole numbers on a number line, addition on a number line, subtraction on a number line, multiplication on a number line, and division on a number line. So if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you. Have a nice day. Hello and welcome back everyone. Today we're going to continue with the same topic, whole numbers. But now we're going to learn about subtopic, which is patterns in whole numbers. So let's start the lesson. What are patterns? What do you mean by it? A pattern is like a regularity in the world, like in human-made designs or in paintings or in abstract ideas or even in math problems. It's like a decorative design or model which is being repeated many times. A pattern is the repeated or regular way in which something happens or is done. In mathematics, a pattern is like a repeated arrangement of like numbers, shapes, colors, many more things. An example of pattern is like two orange triangles, then two brown rectangles, two orange triangles and two brown rectangles. So now let us study like an interesting way in which we can use patterns to arrange whole numbers in squares, triangles and rectangles using small dots. Okay, so let us learn about triangular numbers now. Like numbers such as 3, 6 and 10 are represented by dots in the shape of triangle. These numbers are called triangular numbers. A triangular number or triangle number counts objects arranged in an equilateral triangle. The triangular numbers up to 100 are 1, 3, 6, 10, 15, 21, 28, 36, 45, 55, 66, 78 and 91. This is an example of triangular number. It shows up to the fifth triangular number. The first one is just 1, which is small dot. Second one is 3 dots, which is in the shape of a triangle. Third one is 6 dots. Fourth one is of 10 dots and fifth one is of 15 dots. Now, let us continue to learn more about triangular numbers. If a question asks like, what is the 12th triangular number? It is too difficult to draw out and find out so much. In that case, we will use the below method. Triangular number of nth number is equal to n into n plus 1 divided by 2. So this means that triangular number of 12th place. So we'll replace the n with 12, which will be 12 into 12 plus 1 is divided by 2, which will equal to 12 into 13 divided by 2. 12 into 13 divided by 2 is equal to 78. Now, let us learn about square numbers. Numbers such as 4, 9 and 16 can be represented by dots in the shape of a square. These numbers are called square numbers. A square number is basically any positive integer which is multiplied by itself. The square numbers up to 100 are 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. So these is an example of square numbers. It shows the first 5 square numbers. So in the first square number it's like 1 dot. Second square number is of 4 dots, which is in the shape of a square. Third is of 9 dots, which is on the shape of a square also. Fourth is 16 dots and fifth is 25 dots. Let us continue learning about square numbers. If a question asks like what is a 12th square number, it is too difficult to draw out from 1 to 12 all these square numbers. So in that case, we will use this below method. Square number of the nth number is equal to n into n, or n to the power of 2. Square number of 12th place will be 12 into 12, which is equal to 144. So now let us learn about rectangular numbers. Numbers such as 2, 6 and 12 can be represented by dots in the shape of a rectangle. These numbers are called rectangular numbers. A rectangular number is a number in which the product of two consecutive integers. The rectangular numbers up to 100 are 2, 6, 12, 20, 30, 42, 56, 72 and 90. So the first rectangular number is 2. It has 2 dots and it is in the shape of a rectangle. Second has 6 dots and it is also in the shape of a rectangle. And third has 12 dots, which is in the shape of a bigger rectangle than the second one. The fourth one has 20 dots and the fifth one has 30 dots. Now let us continue learning about rectangular number. If a question asks like what is a 12th rectangular number, it is too difficult to draw and find out. So in that case, we will use this method which I am going to show you now. For a rectangular number of nth number is equal to n into n plus 1. So the rectangular number of the 12th place will be 12 into 12 plus 1, which is equal to 12 into 30. For more easy answers, I am using the distributive property. I have taught about distributive property in my previous lesson. So the link of that video will be in the description. That is equal to 10 plus 2 into 13. So that will be 10 into 13 plus 2 into 13. And 10 into 13 is equal to 130 and 2 into 13 is equal to 26. So 130 plus 26 is equal to 156. This is an example of that. Now we will learn addition and subtraction using number pattern. It is simple to add or subtract a number if one number is near to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 200 and so on. So for our first example, it will be 123 plus 999. So 123 plus 999, we will convert 999 to 1000. So 123 plus 1000 minus 1. 123 plus 1000. So we'll put 123 plus 1000 in a bracket. And then after doing that addition, we will minus 1 from it. So it will be 1123 minus 1, and 1000, that is equal to 1122. So this is our second example. 134 minus 80. 134 minus 20 plus 2. We converted 18 to 20. So we put 134 minus 20 in a bracket. 134 minus 20 is equal to 114 and plus 2. So 114 plus 2 is equal to 116. So what did we learn today? Today we learned what are patterns, triangular numbers, how to find out triangular numbers of given place, square numbers, how to find out square numbers of given place, Rectangular numbers. How to find the rectangular numbers of given place and addition and subtraction using number pattern. So if you guys like the video, please like, share, subscribe and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Hello and welcome back everybody. Today we're going to continue with the same chapter, whole numbers. And this is our new subtopic, closed under which mathematical operation. So let's start the lesson. 5 and 4 are whole numbers. 4 plus 5 is equal to 9 and 9 is also a whole number itself. 35 plus 45 is equal to 8. 35 and 45 both are whole numbers and 80 is a whole number itself also. Similarly, 250 plus 95 is equal to 345. So, all these three numbers are also a whole number. So, for the last example, 29,000 plus 41,000 is equal to 70,000. Also, again, these three are a whole number. So, we can say that when we add two whole numbers, we get a whole number. Thus, we say that whole numbers are closed under addition. This statement, whole numbers are closed under addition, is just the mathematical way of saying whole numbers. When we add two whole numbers, we get a whole number itself. Is whole numbers closed under subtraction? When we subtract two whole numbers, do we get a whole number itself? 44 minus 14 is equal to 30. We subtracted two whole numbers and we got a whole number again. When we subtract 10,000 minus 9,999, we get 1, which is a whole number itself. What about 6 minus 16? What will we get when we subtract 16 from 6? Wait a moment. Can we even subtract 16 from 6? No, we can't do that. And if we try to subtract them, here's what we get. A negative number. I'm not talking about negative numbers now in this lesson, but I will teach you what negative numbers are in the future lessons. Minus 10 is certainly not a whole number. Minus 10 is a negative number, not whole number. Similarly, if we subtract 44 from 14, we will get a negative number. And minus 30 is a negative number, not whole number. Hence, we will deem this operation invalid. Both numbers are not whole numbers. So, we can say that whole numbers are not closed under subtraction. About multiplication. Are whole numbers closed in multiplication? Yes, whole numbers are closed under multiplication. Whenever you multiply any whole number with another whole number, we will always get a whole number. Here are a few examples to support this argument. 5 times 10 is 50, which is a whole number. 23 into 10,000 is equal to 23,000, which is a whole number again. Now, let us involve the whole number 0. 0 into 20,000 is equal to what? Whenever we multiply any number with 0, we get a 0. So, the answer is 0. When we take any two whole numbers and multiply them, the answer we'll get is always a whole number. Now, whole numbers are closed under multiplication. Are whole numbers closed under division? Now, we will get to know. If we divide two whole numbers, will the answer always be a whole number? So, first if we divide 44 by 2, we get 22. And 22 is a whole number. If we divide 6 by 5, we will get answer as decimals, which is not a whole number. Similarly, examples such as 3 divided by 12, 4 divided by 10, and 96 divided by 10 will result in decimal numbers, not whole numbers. Hence, we say that whole numbers are not closed under division. So, this is a summary of what we learned today. We learned that whole numbers are closed under addition and multiplication, and whole numbers are not closed under subtraction and division. So, what did we learn today? We learned whether whole numbers is closed under addition, whether whole numbers is closed under subtraction, whether whole numbers are closed under multiplication, and whether whole numbers is closed under division. So if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day.